Okay, the second lesson, or the second part of your notes for lesson 1-3 picks up with part B. This is from example 2 under complex numbers. All right, this first one just shows subtraction. So before you get going here, you want to distribute your subtraction. Remember that changes the sign on the 3i. Then I'm going to add real with real. So 4 and -5 make -1 if I add them together. And -5i and 3i would be -2i. If you wrote your answer this way, that would be counted wrong. Remember, you want to write your answer in standard form. The second one, if I square a quantity, that means I FOIL. So I will have 25 for my first, my outer, inner, and last. So this is 9 times a -1. If I see I squared show up, I have to switch it to a -1. They are equivalent. So now I have 25 minus 9, so 16 and 30i. On D, I'm also foiling 9 minus 8i and 9 plus 8i. So I will have my first terms are 81, outer, inner, and last. These two have opposite middle terms, so they're going to go to 0. This is a -1 times 64, negative. So this is actually 81 plus 64, and that's 145. Now, 9 minus 8i and 9 plus 8i are called complex conjugates. Anytime you multiply complex conjugates together, you get a real number answer. So you get an answer without I in it, which is super important for when you get to these problems where you're dividing. Having 3 plus I in the denominator is like having 3 plus the square root of -1. And you don't want to use, you don't want to leave a problem with an I in the denominator. So what we're going to do is we're going to multiply by the conjugate of the denominator, and that way we produce a real number from there without something without I in it. If I divide by 3 minus I have to also multiply on the top by 3 minus I. On the top, I need to FOIL. So 15 minus 5i minus 15i plus 5i squared. All divided by, and then I can FOIL the bottom as well. 9 minus 3i plus 3i minus I squared. Remember, your I squared is -1, so this will become 10 minus 20i all over, and then 9 plus 1 would be 10. Remember that when you reduce, you want to reduce this way to get 1, and you want to reduce this way to get -2. Okay. This will come up in your homework as well. If you had something like 5 minus 6i over 2, you would still want to split it up into 5 halves minus 3i. So go ahead and do this. And if you had me in pre-calc, I called that making the heart, because once you loop both ways, it looks like a heart. So go ahead and do that. Okay, we're going to try that again on F. So -3 plus 4i over 2 minus I. And again, you want to get rid of the I in the denominator, and the best way to do that is to multiply by the conjugate of the denominator. We FOIL on the top. Now I shortcutted my foiling on the bottom because conjugates always have the two middle terms that fall out. So you could do 4 plus 2i minus 2i minus I squared, but those middle terms fall out. So I will shortcut that denominator a little bit. Remember that I squared is a -1, so this is 4 times a -1. Added to -6 would be -10. And then minus a -1 will make that a 5. Reduce both ways, -2 plus 1i. And again, I'm taking these two and these two. And G. G is just showing you that even this type of problem can be done by using the conjugate of the denominator. So 4 divided by I can be written this way. And then if I multiply by the conjugate, I'll have -4i over, and then when I FOIL that out, I'll just end up with -I squared. And so I get -4i back. Okay, here's the rest of your practice problems. Make sure you finish those. Your submission's going to be pictures of all of your notes with all of your practice problems, and you'll submit that under lesson 1.3's assignment.